All right, circles. There's two main things that we need to know about circles. One is their center, and the second thing is their radius. Center and radius. All right. And so if we think about like a circle, like for example, in the Cartesian coordinate system here, let's see here, we could have, say, I don't know, this circle. Ooh, that is not circle looking, but you get the idea. All right. But, and let's say that this is the point, I don't know. Let's say this is 4, and let's say this is 2, and this is the XY plane. And make sure you're taking notes as we go, because I'm going to kind of go fast-ish. Hopefully not too fast. But as you all know, I'll give you as many resources as possible. I should record this, honestly. So let me go ahead and start recording. Okay. All right. So the first thing that we're going to do is determine the center here. So the center of this circle, even though it's not a great looking circle, would be the point 4, 2. Now this is important when it comes to determining the equation of this circle. So we're at the point 4, 2, and the center obviously is this where the center is. The radius, if you'll remember, radius is just the distance between the center and any point on the circle, right? So like, for example, this distance would be the same as this distance technically should be, or whatever. So in this case, we have the centers at 4, 2. You can actually kind of tell that if I touch just the x-axis, this radius should be 2, basically. So if I was to write an equation, all right, so if we're writing an equation for this to circle, we're going to use the standard form x minus h squared. Yes, you're going to want to write this down. Plus y minus k squared is equal to r squared. All right. So as we know, hk, it represents the center point. It's the center. And r is going to be representative of your radius. So in this case, your h value would be 4. So h would be 4, and your k value would be 2. So what you're going to have is you have x minus 4 squared plus y minus 2 squared equals 2 squared, because r is 2 in this case. And if you were to kind of multiply this out, you'd end up with, or square the other side, you end up with x minus 4 squared plus y minus 2 squared is equal to 4. All right. All right, so here's your challenge. Basically, you're going to write the standard form of an equation. Okay, so this is format that we're talking about is called standard form, or it's standard form. So you're going to write the equation of a line of a circle in standard form, where r is equal to 10, and the center point is -6, 8. So I'm gonna give you just a minute. Determine, see if you can write an equation in standard form. So the standard form is the format that we've been working with, whose center is -6, 8, and this radius is 10. I'm going to use a different color, I think. All right, guys. So we're trying to write an equation where the radius is 10 and the center is -6, 8. All right. So here's how we're going to do this. Basically, we're going to rewrite it in our standard form. So Basically, we know our H value should be -6. Our K value should be 8. So in this situation, we can say X, remember it's X minus H. So it's X minus -6. So be very careful about that part. Just X minus -6. Then you're going to have plus Y minus K. So Y minus 8 there. Okay. Y minus 8 there. Squared equals R squared, which is 10 squared in this case. 10 squared. So here's the thing. You got -6 here. So it's really +6. So you have X plus 6 squared plus Y minus 8 squared equals 10 squared, which is 100. Okay, everybody go with that? So now what we're going to do is I'm going to go into Desmos and just actually check and make sure that this is indeed right. So the way I'm going to do that is I'm going to say, okay, I've got X plus 6 squared plus Y minus 8 squared equals 100. And we can pretty much see by just the way that it kind of looks that our center here is at -6, 8. That's our center right there. And you can see that it is exactly, so if this is -6, 8, the top is 18, and the below, if you go straight below, is also is -2. You can see that the distance between those is 10. So that's exactly what we wanted. All right. Now we're going to talk about putting this equation in general form. And once again, we should be on page 9 for those of you who are in the book. We're on page 9, but now we're going to talk about putting it into general form. Now, the general form of an equation of a circle. So we talked about standard form. Now we're going to get to general form. The general form is X squared plus Y squared plus AX plus B but Y plus C is equal to 0. So this is the general form of an equation here. This is right here. So how do we turn something from standard form into general form? We FOIL it out, or we multiply it out. And so we're going to go ahead and do that now. So we're going to take our standard form. Let's change the color here. Use this lime green. So we're going to take our standard form, and we're going to do a couple things here. The first thing I'm going to do is I'm going to say, okay, I got X plus 6 times X plus 6. Make sure you're working out with me. Y minus 8. Y minus 8. If you guys don't mind, just kind of put yourselves on mute for right now. All right, thank you very much. And then we got X times X, which is X squared. Let me see, am I going to? Okay, we're good. X squared plus, so yeah, X times X, and then we're going to do X times 6. So that's going to be 6X. And then the next step is we're going to do 6 times X, kind of like that. So 6X, and then 6 times 6, which gives you 36. And we're going to do the exact same thing with the Y's. With the Y's, we'll have Y squared, then -8Y, then -8Y again, plus 64 is equal to 100. So once again, just multiplying out or FOILing out both squareds there. Then what you'll end up with is we have X squared plus 12X plus 36, just combining like terms, plus Y squared minus 16Y plus 64 is equal to 100. Then we're going to put everything into actual standard form. We got x squared first, then y squared. We're going to take our, we'll call, these are basically our linear terms. So 12x, we're going to put that there. And then minus 16y. And then we're going to have 36 plus 64, which is 100, is equal to 100. Now, the great thing about this is that you can see that if I were to subtract 100 from both sides, because you don't want any numbers on the right side, you want it to be equal to 0. Because if you go back to the general form, we see that last term should be 0. So if I were to subtract 100 from both sides, I'll end up with x squared plus y squared plus 12x minus 16y equals 0. All right. Okay. So let's take a look at problem 2. Problem 2, you got an A part and a B part. So x minus 2 squared plus y plus 3 squared. And please mute your volume. Thank you very much. Equals 25. Okay. And the question is, you want to determine the center and you want to determine the radius. So I'm going to give you guys a minute to work on that. In the meantime, we'll go ahead and write down the next one. We got B is. All right. So I'm going to divide everything by 2. Well, hold on. Let's do A first. So for A, I want you to put, so for A, we got the center would be 2, -3, because remember it's x minus h. So you can think about this. If it's minus h, then positive 2 is actually going to be our h value. Same thing. If it's minus k, this is really the same thing. A positive would be the exact same thing as saying minus k. So it would be -3 would be your k value. Then remember it's equal to r squared. So if I go back up to our standard form, right? Our standard form, it's equal to r squared. So you actually have to take the square root of that last number. So the radius would be 5. Okay. Any question? Yeah. Now, if we want to figure out the same thing for the next set, excuse me, we're going to divide everything by 2. So you end up with x plus 1 squared plus y minus 2 squared is actually equal to 5. Right? If I divide everything by 2, and I can do that because remember with equations, it's like a balancing act. If you can do whatever you want to one side, just as long as you do that to the other side as well. So basically what we've got here is what we do. Let's see. In this case, our h value would be -1. Our k value would actually be +2. And if it helps, you can just think h and k are kind of like opposite sign of what's in the actual equation. And so you got -1, 2, and then your radius would be the square root of 5. Note, your radius wouldn't be 5 here because you have to take the square root to find the radius. All right. There's one more. There's a couple more things I want to talk about circles, and then we will take our 5-minute break. Yeah, so the radius is the square root of 5. Square root of 5, because remember, once you get it into this format, this 5 actually represents r squared and not 5 itself. Okay. All right. So now we're going to be talking about turning something going from general form into standard form. So we're going to start with problem 3. So we got problem 3. We've got x squared plus y squared plus 14x minus 10y plus 73 is equal to 0. I'm going to pause right there because I'm going to make sure everybody has that down. Make sure everybody has that down. So for this, I'm going to share something with you guys real quick. For this, I'm going to use completing the square. Now, I'm going to go over completing the square in this lesson, but it is, if you're not used to it, can be kind of a confusing topic. So let me pull up something real quick just to show you all. I have the extra lecture notes always under files, and you can go to my personal lecture notes, literally under extra lecture notes. You go to my personal lecture notes, and the one I put for lesson 2, it has a much more thorough explanation of completing the square. So if you're freaked out by what I'm about to cover, don't be. I have a very step-by-step, succinct explanation of using completing the square. So just be aware of that. But I'm going to do it, and I'm going to do it fast-ish in the name of time. All right, so the first thing you're going to do is you're going to group all your x's together, group all your y's together, and put the numbers on the other side. So what do I mean by that? Basically, I'm going to end up with x squared plus 14x plus y squared minus 10y equals negative 73. So that's kind of the first thing you're going to want to do. Okay. Then what we do is we complete the square. Now, to complete the square, you look at your linear term. So linear term just means it's the term that has just x or just y. It's not like y squared or, y cubed or something like that. It's just x. So like this would be 14x. That's our linear term. Negative 10y, that's your linear term. You're going to take your linear term. We're going to denote these linear terms via the variable b. So we're going to call these our b's. You'll see why when we cover the quadratics lessons. But basically, the formula is this. You're going to take that number, cut it in half, and square it. Okay? And we're going to take this number, cut it in half, square it. Okay? So let's walk through that real quick. So for our x values, what we're going to do is we're going to have 14 over 2, and you can either write this right under or write this to the side. But 14 over 2, as we know, is 7, and then 7 squared is 49. And for the other one, we've got negative 10 over 2 is negative 5. And then negative 5, if you square it, is 25. Just hold on to those for now. Let me use a different set of colors, I think. But just hold on to that for now. We're going to bring that back in a minute. So the first thing we're going to do is this. We're going to say we're going to have x squared. We're going to have x squared plus 14x. But now we're going to actually add the b over 2 squared part to the end of that. Same thing for the y values. We're going to have plus y squared minus 10y plus 25. But here's the thing. Note, we added 49 to this side. We added 25 to this side. We have to do the exact same thing to the other side. So we're going to add 49. We're going to add 25. All right. Now, why in the world would we do any of that? Well, it's because it turns out that when you do this, these three terms turn into X plus whatever this number ends up being, and then squared. Okay. Once again, this is what we call it completing the square, because we're trying to get it back to something that's squared. You can check that by just multiplying this back out, x plus 7 times x plus 7. So similarly, for these three terms, you're going to end up with x, or rather y, minus 5, because that was the b over 2 term, squared. And this is then equal to, let's see, 49 plus 25 is going to be 74, I think. Yeah, 74. So that's equal to 1. So you got negative 73 plus 49 plus 25 is 1. And now, if I ask you what the center and radius is, we can see quite easily that the center's at negative 7, 5. We can see that the radius is 1. And we can even determine our x and y intercepts from this too, right? Because remember, an x-intercept occurs when y is equal to 0. The y-intercept occurs when x is equal to 0. So if I wanted to figure out, say, so we'll say x-intercept, all I have to do is set y equal to 0. So to do that, we'd have, let's see.
Wouldn't the radius be square root 1?
Yes, you are correct.
Okay.
But then you got to think, what is the square root of 1?
Well, that's what I was. Do we put it in the quizzes and stuff as square root 1 or the actual decimal number?
The actual decimal. You would use the actual decimal number, because the square root of 1 is actually 1.
It's actually 1, yeah.
Yeah. But no, that's a good note. That is a good note. It's still square root though. Great comment. All right. So what we want to do is, so the x-intercept, basically you set y equal to 0. So you can think about this. It's going to be x plus 7 squared plus negative 5 in parentheses squared. And that the in parentheses does matter. It is important. Remember, I'm just setting, all I've done is set y equal to 0. So basically you'd have, let's see, you got x plus 7, and I'm just going to keep it like this, squared plus 25 is equal to 1. And then you end up with x plus 7 squared equals negative 24 when you subtract 25 on both sides. Now, there comes an issue here. The issue is, to solve this, I'd have to square root both. I'd have basically x plus 7 equals the square root, technically plus or minus, right? The square root of negative 24. But the problem is, this is imaginary. So what does that tell you? There is no x-intercept. All right, so for the y-intercept, that's where we're going to set x equal to 0. And so setting x equal to 0, you end up with 0 plus 7, which is 7 squared basically, plus y minus 5 squared is equal to 1. Let's see, 7 squared is 49 plus y minus 5 squared equals 1. If you subtract on both sides, you'll get, once again, a negative number, 48. So you'll see there's no y-intercept either. So let's check. And so the way I'm going to check that is I'm going to actually go back to the very original problem and see if we can't get everything that we expected. So we were told it's going to be x squared. So x squared plus y squared. What else was it? Plus 14x minus 10y plus 73 is equal to 0. And here you can see it. We can see that indeed. Let's see what all our predictions were. Prediction was that the center was going to be at the point -7, 5. And boom, you can see it. It's right there. We predicted that the radius was going to be 1, and that is true. And there are no x-intercepts, and there are no y-intercepts. Yep. All right, guys, we're going to take a 6-minute break. We'll reconvene at 6:20. So if you need to stretch your legs or do whatever, you can do that. If you have any questions for me specifically on this, you can ask those as well. But we will, like I said, reconvene at 6:20. So I'm going to go stop sharing and see if there are any questions so far. I'm going to skip 4 because I kind of literally just talked about that. If your center's at the origin, guys, that means H and K are both 0. So all you have to do is plug in R in that case. For 5, the standard form of the equation, having a center at 0.26 and tangent to the y-axis. Whenever you hear something that says tangent to, so tangent to, and once again, let me rewrite the problem. So your center was the 0.26, and it was tangent to the y-axis. So what in the world does tangent to mean? Tangent to means touching, right? So if we think about it, if my center's at 2.6, and I'm a visual person, so you just have to roll with me. But if my center's at 2, and we'll say this is 6. So this is 2.6. And I'm tangent to the y-axis. That means, remember, tangent means touching, but notably touching at only one point. So if I'm tangent to the x-axis, that means I only touch the y-axis at one point. Therefore, R has to be 2. Why? Because it has to be the exact same distance between this point and that y-axis. If I said it was tangent to the x-axis, then I would be looking at this orange line instead, or peach line, whatever you want to call this, orange, whatever. So this would be tangent to the x-axis, right, versus tangent to the y-axis. So in this case, we can actually say that R is equal to 2. And then we can go from there. We plug everything into our standard format. X minus 2 squared plus y minus 6 squared equals 4 squared, or rather 4, because 2 squared is 4. And that we're done. Okay. Number 6, find the standard form of an equation with a circle with endpoints of the diameter at 2 different points. Oh, these are interesting. All right, so here's the deal. We're told that the endpoints of the diameter, okay, the endpoints of the diameter are going to be 5, 6, and -1, 2. 5, 6, and negative 1, 2. So visually, the way I like to think about this is basically we've got the point 5, 6, which should be, I don't know, maybe out here somewhere. This is 5, 6. And we got the point negative 1, 2, which is probably right here somewhere. And you're trying to find the center and the radius of this point, or between these two endpoints. Now, to find the center and radius of between these two endpoints, because here's your circle, kind of, sort of, right here. Obviously, to find the center, we're going to actually find the midpoint. And we know how to find the midpoint. The midpoint is x2 plus x1 over 2 and a y2 plus y1 over 2, which in this case would be, I'm just going to do it in my head, but 5 minus 1 is 4 over 2 is 2. So the center would be 0.2, see, 8 over 2, 4. Okay, so that would be my center. Okay, now to find the radius, here, what I'm going to do is I'm actually going to use the distance formula between the midpoint. If you think about it, the radius is just going to be the distance between the midpoint and one of my endpoints. So to find the distance between the midpoint and my endpoint, or the distance between the center and my endpoint, I'm going to use the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared, which in this case, the endpoint I'm going to use is the 5, 6 endpoint, but you could use the other one. So I'm going to have 5 minus 2 squared plus 6 minus 4 squared. 5 minus 2 is 3 squared plus 6 minus 2 is 2 squared, which is the square root of 9 plus 4, which equals root 13. So note the center's at 2, 4. The radius is the square root of 13. So if I put it all together, I have x minus 2 squared plus y minus 4 squared equals the square root of 13 squared, which the square root of 13 squared is just 13 itself. Okay, everybody cool with that? I'm going to take that as a yes. Let's talk about functions. Now, I did a really good illustration. I don't mean to pat myself on the back too much, but I did a pretty good illustration of this in my notes. So I'm going to kind of cover that right now, or my extra notes. So I'm going to kind of use it here. Basically, you can think about a function that is a relationship between two sets. So function is a relationship between two sets where each input is connected to one distinct output. What in the world does that mean? So suppose we have these two sets where we have a set of animals and we have a set of food. A function would be this mapping or this drawing from cows to cheese. Basically, cows go into this function, cheese comes out of the function. And that is a very simple function, but it's a function. Another example of a function would be if you had cows and goats were both in the set of animals, and they both we call map to cheese because cows produce cheese and goats produce cheese. This is okay because every single time we plug a cow into our function or a cow into our factory, whatever you want to call it, you always get out cheese. Okay. Every single time. It's like if you're at a vending machine, you press F6, you're always going to get Cheetos every single time. You don't press F6 and get Cheetos and then press F6 and get Snickers or something like that. And that's the example of a function. Now, this right here is not a function. This is not a function because in this situation, the animal is cow, and cow goes in, sometimes cheese come out. Cow goes in, sometimes cheeseburgers come out. This will be an example of something that's not a function. Now, the animals or the set of inputs, what we're putting into this function or into our factory, this is called the domain of the function. The domain of the function is just setting what type of inputs can be put into the function. So for example, in the domain of animals, screwdrivers would not be in that domain. In the range, stands for the set of outputs. So note, if your domain is animals and your outputs from animals are food, then the range represents the food. Okay, so I'm hoping this illustration kind of makes sense in terms of domain. These are your inputs. Range, these are your outputs. And I apologize to all the vegans out there, but this is just kind of how that rolls. All right, so let's walk through this. Suppose, let's look at problem 7. Suppose you have the situation and it says find the domain and range of the relation, and we're going to talk about the domain and range of this relation and whether it's a function or not. So we got -5, 1, 5, -2. We've got 6, 0, and -5, 2. Now, check this out. Basically, we have a situation where all of the first numbers denote our inputs. Okay. So in this particular function, if I input 5, or this particular relationship, if I plug -5 into my factory, so you can think about this like as a little factory. If I plug -5 into my factory, I get 1 out of my factory because these are the set of outputs. These are your outputs. Second number denotes your output. So the domain, as we said, was the set of all inputs. So in this case, the domain would be -5, 5, and 6, because those are the only inputs, right? There's a -5 here, a 5 here, a 6 here, a -5 here. So we're not going to count it. I'm not going to count it twice. The range is a set of all outputs. So it's going to be 1, -2, 0, and 2. All those second numbers, basically. However, in this particular situation, we can say that this is not a function. And it's not a function because for the input -5, I get out 1 in one instance, but for the input -5, I get 2 out in another instance. Well, that's not a function because you can imagine, if you had a vending machine, you every time you press F5, you want to get the exact same thing out every single time. And obviously, this is not a situation where that is happening. Now, a little bit more sophisticated, we have functions that we can denote through an equation. And these functions we can note by the equation f of x, which literally means function of x. All right. So f of x, the whole thing denotes the output for a particular function. So I'll give you an example. So if you have f of x is equal to x plus 5, okay? So here's what's going to happen. Basically, we're going to take some x value. Let's say we take the x value of 1, okay? We're going to plug it into x plus 5 because this side, the right side of the equation, tells us the set of instructions that should happen to x once it enters into the equation. So that'd be 1 plus 5, which yields 6. So here's what we can say. We can say f of 1 In other words, if I input 1 into my function, that is equal to 6. And that's it. So for example, if I said, okay, what is f of 3? Well, that would be 3 plus 5, and that would be 8. So f of 3 equals 8. All right, let's take a look at problem number 8. With that in mind, we'll take a look at problem 8. Problem 8, you're given that the function f of x is equal to 3x squared plus 2x plus 6. 3x squared plus 2x plus 6. And we're going to look at a few of these. So for problem A, we're asked to find f of -3. Okay. So f of -3 is going to be 3 times -3 squared plus 2 times 3, 2 times -3 rather, plus 6. No, basically everywhere I had an x, I have now replaced it with -3. I'm gonna pause right here because I feel like I'm going too fast. But basically all I've done is everywhere there was an x, I have replaced it with parentheses -3. So anyway, we got 3 times -3 squared. Now let's think about it. -3 squared is -3 times -3, which turns it back positive. Positive. So 9 should be -9, should be +9. So in this case, we've got 3 times 9, which is 27. Now 2 times -3 on the other hand is definitely -6. And then you add 6. So 6 is basically cancel, and you're left with 27. So I'm just going to kind of roll through the rest of these. Basically, if I plug -x in to our function, I have -x squared and then -x. So everywhere there was an x, I have replaced it with -x. And when you do that, -x squared actually turns it back positive. So you get 3x squared. Of course, 2 times -x is just -2x. You have plus 6. If you put a negative in front of everything, then that's literally what you do. You put parentheses around the whole thing and then put negative, and then just distribute the negative out. And then finally, if you have x plus h, what you do is a little more complicated, but this is actually very important for limits when you get to that 106, I think. 106, if I'm not mistaken, or if you get to limits. And so you have x plus h, where once again, everywhere there was an x, we are now replacing with x plus h. We replace this with x plus h. X plus h squared would be x squared plus 2xh plus h squared. Just foiling it out, you can go back and check. But I'm kind of pressed for time here. So we multiply 3 out by all of these, with 3x squared plus 6xh plus 3h squared. And then you just combine your like terms, of which there are none. So you're done. All right, let's talk about the domain of a function for a second. When we're talking about the domain of a function, basically, remember, we're saying a domain is the set of all possible inputs. Well, there are 2 big no's. Okay, there's 2 big no's when it comes to functions. The first big no is you can't have a 0 in the denominator. So whatever you do, that denominator cannot be equal to 0, right? This is what I wrote here. So if that denominator can't be equal to 0, to figure out the domain, I'm actually going to set it equal to 0 and figure out where that occurs. Because if I can figure that out, I can say, okay, well, I can't happen at these particular situations. So let's walk through this. So here's what I did. I have x cubed plus 3x. I don't want it to be 0. So I'm going to set it equal to 0 here. So what I did right here. So set it equal to 0. And then what you can do is, since there's an x here and there's an x here, you can factor an x out of both. And you're left with x squared plus 36 because I factored an x out of both. So that means that I can either set x equal to 0 specifically, or I can set x squared plus 36, which is this part, equal to 0. And if I do that, I will subtract 36 on both sides. But once again, I hit this wall where if I have x squared is equal to negative 36, if I square root both sides, I'll square root a negative and get an imaginary number. So there's no solution here. I don't even have to worry about this part. So the only part I really have to worry about is x is equal to 0. In other words, if I plug 0 into this function, and I know I did a lot of talking, but hopefully this will actually make sense now. If I plug 0 into this function, what I'll end up with for f of 0 is 0 plus 5 all over 0 cubed plus 36 times 0, which would give me 5 over 0, which this, as we know, is undefined. So basically my domain is everywhere. That's what this denotes. Domain is everywhere except 0 itself. And that's it. Now, in terms of interval notation, I want you guys to note the interval notation here. Basically, what I'm saying is my x value could be anything negative. I could be at negative 1,572,000. Doesn't matter how negative I get, but I can't be 0 itself. So what you use in this situation, we denote that, too much. Okay. We denote that by putting in a parentheses. So whenever you want to exclude a value, because we don't want 0 itself, I can get as close to 0 as I want, but I can't get to 0 itself. When I want to exclude it, I use parentheses. All right. If I wanted to include 0, I would use a bracket. So I'm going to exclude it with the parentheses, and I'm going to say union, which means and, basically, 0, parentheses, to infinity and beyond. All right. So we've got, let's take a look at part B. For part B, I can't have a situation where obviously this is negative. However, in other words, I can't have where 2x minus 16 is negative. If I have that, I'm going to be square rooting a negative, and we've already talked about that. If you square root a negative, you get an imaginary number. So I can't have this be 0. However, it can be 0 itself and anything bigger. So to do that, you can see this first line. I'm just going to set this greater than or equal to 0 because it needs to be either bigger than 0 or 0 itself, which gives me 2x is greater than or equal to 16. And if I divide 2 on both sides, you end up with x has to be greater than or equal to 8. So note, I actually include 8 here because I can have the value 0. If I plug 8 in here, I get 2 times 8, which is 16 minus 16 is 0. The square root of 0 is 0, just like the square root of 1 is 1. Those are 2 weird numbers there. But it's included here. Note bracket, included. Now, C is kind of interesting because not only do you have to deal with stuff that's not less than 0, so non-negative, but also since the square root is on the denominator, as you all will note with the bell ringers, since it's in the denominator, it can't be 0 itself either. So if you have a regular square root, you can have equal to 0, but if it's in the denominator, you can't. And so once again, we need it to be strictly greater than 0, where you subtract 4 on both sides, and you easily get negative 4 to infinity. All right. So I'm going to run through these really fast because we only have 3 minutes, but use a given graph of the function of x to answer the following questions. All right. First thing says find f of negative 12 and f of 0. F of negative 12 means where x is negative 12, so that'd be negative 12. What is the y value? Because you can think of f of x or f of negative 12 as your y value at 12. So f of negative 12 would be negative 6. So you can see that right there, negative 6. F of 0, all right, so where is x equal to 0? So x is equal to 0, y is equal to 6. So f of 0 would be 6. Is f of 10 positive or negative? Well, let's look at 10. If you have f of 10, which it's got to be about right here, right? Because if this is 8 and this is 12, then obviously it's got to be between those two. So 10 is probably about right here. And we can see that this value would be above the x-axis and therefore positive. How often does we cross the line y equals 4? We can think about it like this. You could draw a line right here where y is equal to 4. It's a horizontal line. You would hit it 2 times and therefore twice. For what values of x does f of x equal -4? You can see that f of x equals -4. Note, the question doesn't say what is f of -4. It's asking where is f of x equal to -4. That's important because f of x equal to -4 means your output is -4, not your input. So if your output is -4, that occurs here when x is equal to -10 and when x is equal to 16. Domain, you can think about is all your x values. So the lowest value x you have is -12. The highest value you have is 22. So it's between -12 and 22 in the x direction. Note included. Also, the range would be from -6 to 8 because the lowest value, the lowest y value, because think range, your y values. Lowest y value is -6. The highest y value is 8. And I know we're out of time, but give me just a couple minutes. We're on the last problem, I promise. All right, we're talking about operations. Now, operations on functions are just like regular operations. You can add functions together, you can subtract functions, you can multiply functions, you can divide functions. And you can see some examples of this. If you have f of x is equal to 5x plus 4 and g of x is equal to 7x minus 3, and you subtract the two, all you would do is multiply the negative out and you would combine your like terms and so on and so forth. Same thing with multiplying the two values and dividing. The dividing, if you divide the values, however, note that your domain will probably be restricted because your denominator cannot be 0, as we talked about. And that's it, guys. I appreciate you indulging me that 1 minute.